Welcome to the presentation of Course 3. Our topic was the interpreter programming. This is the introduction of interpreter. We generally write a computer program using a high-level language. A high-level language is one that is understandable by humans. This is called source code. However, computer does not understand high-level language. It only understands the program written in zeros and ones in binary, called the machine code. To convert source code into machine code, we use either a compiler or an interpreter. This is known as a language processor. With interpreter, line-by-line execution of the program takes place. Hence, if an error occurs, the execution will stop at the errors and the user will be made aware of it. Next topic is why introduce. Interpreter were used as early as 1952 to years programming with the limitation of computing at the time. The main advantage of introducing interpreter was that they could directly execute instructions written in a program or scripting language without requiring them previously to have been compiled into a machine language program. This allows the users to save time during program development and since interpreter makes the use aware of errors as soon as it runs into them. This further saves development time. Lisp was first implemented in 1958 by Steve Russell on an IBM 700 per computer. Russell had read John McCarthy paper and realized that the Lisp well function could be implemented in machine code. The result was a working Lisp interpreter which could be used to run Lisp program or more properly evaluate Lisp expression.
Since computers cannot directly interpret high-level language, programs written in high-level languages must first be translated into machine code. This is done by language processors. Language processors can be classified into two main categories. The first category consists of compilers and interpreters, and the second consists of assemblers. The main difference between these two is that compilers and interpreters translate programs written in high-level languages into machine code, while assemblers translate programs written in low-level languages or assembly language into machine code. The main difference between compilers and interpreters rises because interpreters translate a program one statement at a time, while compilers take the whole program written in high-level language and converts it into machine code. Because of this, interpreters usually take less amount of time to analyze the source code. However, the overall execution time is comparatively slower than compilers. Compilers, on the other hand, usually take a large amount of time to analyze the source code. However, the overall execution time is comparatively faster than interpreters. Interpreters are more memory efficient since object code is not generated, while compilers require more memory since object code is generated. Programming languages like JavaScript, Python, and Ruby use interpreters, while examples of compilers are C, C++, and Java. An interpreter generally uses one of the following strategies for program execution. It either passes the source code and performs its behavior directly, or it translates the source code into some efficient intermediate representation of object code and immediately executes that. Else, it explicitly executes stored precompiled bytecode made by a compiler and matched with the interpreter virtual machine. A compiler takes an entire program and converts it into an object code, which is typically stored in a file. The object code is also referred as binary code and can be directly executed by the machine after linking. An interpreter, on the other hand, directly executes instructions written in a programming or scripting language without previously converting them into an object code or machine code, one statement at a time. This means that a compiler doesn't require the source code during execution, and it only requires it during compilation. An interpreter, on the other hand, requires the high-level programming source code each time the program is run. This is an example for how a compiler works.
Improvements. Dynamic language framework. Most dynamic language in wide use interpreters because that have high runtime computability and reducing scalability. Stackless. Latest interpreters come by default with stackless mode, providing microthreads for massive concurrency. Serialization. Latest interpreters have features ability to pause execution, serialize current state, then resume the execution at the point at a later time. Loops, variables, clauses, and all other state preserved. And self-modifying codes and JIT compilation are another revolutionary improvements of interpreters. Recent trends. Creating a new program language or execution environment brings with it the challenge of optimization to remain competitive with alternative environments. Therefore, the application of genetic improvement directly at the compiler or interpreter level to utilize it for programming languages. Neural program interpreters. The neural program interpreter is a recurrent and compositional neural network that learn to represent and execute programs. NPI reduce sample complexity and increase generalization ability. AMID interpreters for genetic programming. Most genetic programming implementation use an interpreters to execute an individual in order to obtain its outcome. To speed up this process, multiple execution, multiple data sets are used the way in a single pass one can execute several instructions on the dataset. And also self-optimizing abstract syntax tree interpreters and linear time self interpreters are recent trends of nowadays. So this concludes our presentation. Thank you for your time.